All right, so going through this set, the first one we see that a number is multiplied by its reciprocal. That is the multiplicative inverse. So the inverse property of multiplication. In the next example, what we see here is we have this monomial factor 77s times the quantity v plus r, and then it gets distributed through, multiplied by the v and the r independently, and then written as a sum of terms. So this is the distributive property. Okay, next we have a sum of two terms added to a third term. And then we see that those same three terms here are in the same order, the 77s, the 49v, and then the r. We just have different grouping terms or grouping symbols around different set of terms. So when the order doesn't change, but the grouping does, that's the associative property. And this is addition, so associative property of addition. Next we have a number plus its opposite. That's its additive inverse, and so that's going to be the additive inverse property, or the inverse property of addition. Okay, next we have these two factors that are being multiplied here. We have the same two factors being multiplied, but we switch their order. An order change is commutative property. And this is a multiplication, so it's of multiplication here. Next we have this sum of terms, 77s plus 49v, all plus r. Then we have r plus the same grouped terms, so the grouping symbols aren't changing. The order is. Again, that makes it commutative property. This time of addition. Next we have a number plus 0 equals itself. It maintains its same identity. So this is the identity property of addition. And then we have a number times 1 to maintain its identity. Identity property of multiplication. And then finally, this last example, here we have 77s times v, all grouped together times r. And then we see 77 times the whole product SVR. We have the same set of factors. They're in the same order. All that's changing here is the grouping. And so that is the associative property. And it's of multiplication.